Okay, guys, the beginning of chapter 9, which we were going to start the last day before school, but we didn't, piggybacks a lot off of the ideas in chapter 8, so it shouldn't be too hard to understand. Now, it starts by talking about a point estimate. A point estimate is really, it looks like a minus sign, but p hat is really equal to x over n. It's just the population proportion that you got from your sample. So if you had a sample of 100 people and 43 of them said they did or didn't like something, then your population proportion would be 43 divided by 100, or 0.43. I know it looks like a minus sign, I promise it's equal sign. So when we look at problem 1, it says in July of 2008, a Quinnipiac University poll asked 1783 registered voters nationwide whether they favored or opposed the death penalty. 1123 were in favor. The point estimate is the number in favor divided by the total number. So what does that mean? Well, you just divide the two numbers to get the actual decimal representation of what 11 that is. So 1123 divided by 1783 is 0.6298. If it doesn't tell you to round, let's round this approximately to 0.63. So that would be what a point estimate is. Not super hard. It's just really the proportion, which isn't so bad. Now, how accurate is your estimate? That's what people really want to know. You know, if you ever look at like the election numbers, you're like, this person has 51% and this person has 48%. And they're like margin of error 3%. But how did they get that margin of error? Well, let's talk confidence intervals. A confidence interval for an unknown parameter consists of an interval of numbers based on a point estimate. So if you look down to problem number 1b, it says that in a random sample of registered voters, 53% favor candidate A with a margin of error of 3%. What is the confidence interval? Well, 53% is 0.53 as a decimal. 3% margin of error is 0.03 as a decimal. So to find the confidence interval, you basically are saying, well, what's the upper bound of my interval and the lower bound? So I have to add or subtract. So 0.53 plus 0.03 is 0.56. 0.53 minus 0.03 is 0.5. Now we can put that in an interval form and say my lower bound 0.50 to 0.56. And that is my confidence interval from lowest to highest number of people who pretty much were fairly certain between 50 and 56% of the people actually favor candidate A. There's another way to put that as well, and that is inequality notation. 0.50 is less than p hat is less than 0.56. But we were just given that 3%. How would we actually be able to find it ourselves? So the confidence interval depends on your level of confidence. And your level of confidence is about how accurate do you want to be. The question is, how accurate do you want or need to be? It usually depends on what you're talking about. If you want to talk about Is a tornado going to hit a city? You want to be pretty confident. Most of the time, people refer to 95% confidence. We were talking about this in the other chapters, whether something is unusual or not. And it was unusual if it was outside like the middle 95%. So that would be like the typical confidence interval, but there's more than that. A 95% confidence interval, what would it look like? So 95% is on the inside of our interval. That means 5% is on the outside, so that means there's 2.5% on the left and 2.5% on the right, which is going to be important on our z-tables. What it means is that if you're estimating the population actual value, you're pretty sure 95% of the intervals, if you created 100 of them, would contain the actual value of the parameter and 5 wouldn't. So the margin of error is going to depend on your level of confidence and your sample size. Generally speaking, as the sample size increases, the margin of error decreases, because the more people you ask something, the closer to the actual value you get, so you have less error in it. And then, of course, the standard deviation. People can vary wildly. The more spread in the population, the wider our confidence interval will need to be. It's like a net. We're trying to catch the actual value, and we need to spread our net wider if people are bouncing all over the place. Now, some rules that still hold. So from chapter 8, we had these rules that, how do we know something's behaving normally? It was n times p times 1 minus p was greater than or equal to 10. And the mean of p hat is just equal to the actual population mean, and the standard deviation of p hat is equal to that same p times 1 minus p over n. And then we know n times p times 1 minus p needs to be greater than or equal to 10 for normality. These three things are still going to hold, just like from chapter 8. And that will be all for now. We'll continue pages 3 and 4 in the next video.